Welcome back to Pure Science Education, and today we're looking at relationships on graphs. The word pattern, trends, relationships means the same thing, and we're going to look at lots of different examples that can come up in GCSE, KS3 and A-level exam. In the first example, I've got Toyko rolling down a ramp, which is one of your physics required practical, and you've got the speed of the car on the one side and the height of the ramp on the other. You get a straight line. So how would you explain this in the exam? The higher the ramp, the faster speed of the car. The speed of the car is directly proportional to the ramp, and the word directly proportional means if the speed of the car increases, the height increases at the same rate and time. Also, that the line will go through the origin, so they both close from 0. Slightly different example this time. We're looking at time of swinging pendulum. We've got length of the pendulum on the bottom and the time on the side. Again, you got a graph which can be broken into stages. Could you see this here, the start of it, and then it starts to kind of curve upwards. So I'll break into two sections. The first section would be the longer the pendulum, the longer the swing for one swing, and as the length increases, the time it takes for the swinging also increases. So it's not directly proportional because it's got this slight curve on here. So this time we're looking at the mass of the pendulum and the time it takes for one swing, and you've got a flat line. So flat line is basically looking at the relationship. So in this case there isn't a relationship because the mass is not making any difference to the time it takes it to swing. So no matter where you are on the scale, the line remains the same. Here's another one, length of wire and current, and you'll see the line, the length of the wire. As the length of wire is increasing, the current is decreasing, basically decreasing at a steady rate. So it's not like a rapid or dramatic decrease. Now we're going to look at a chemistry example. We're going to make gas over time. Again, if you look at the start of the graph, you can break it over here on this point, and then you can break it. There's two parts to the graph. So the first part is the volume of gas is increasing with time. And the second part is but eventually becomes constant, so plateaus off, which then means your reactants have been used up, all the products have been made in that given time. And this time we're going to look at a biology example, which is rates of enzyme over pH change. This graph's quite a tricky one to explain. It has different stages, so there's one here, there's a little curve here, and then so on. So let's look at it differently in different places. So as the pH increases, the rate of reactions also increasing over the pH. And if you look at this, I've specifically put 5.5. So you realize that until 5.5, the pH, the graph is going upwards, so the rate of enzyme is increasing. So pH 5.5 is your optimum temperature. That means the perfect temperature for the enzyme to work at. And after that, you see this decrease in the rate as the pH increases because it's either not working if it's pH 6, 7 or beyond, so it doesn't like the alkaline conditions. So the pH is decreasing for those reasons. Thank you for listening and watching. Hope this was useful. See you next time, and don't forget to subscribe.